Hi, I'm Vanessa at the University of Colorado Anschutz Medical Campus, where we develop and apply mass spectrometry-based methods to investigate the role of metabolites in microbial communities relevant to human health. In this video, I will provide an example of how the GNPS dashboard can be used to check raw LC-MS data to diagnose upstream data issues. These issues could originate from sample preparation, including poor extraction, or instrumentation problems such as missed injections or decreased sensitivity. This example is provided as a supplemental use case for the GNPS dashboard paper. In this example, we will be using LC-MS metabolomics data available in the massive community resource. This data was generated from extracts of in vitro cultures of 7 strains of the opportunistic pathogen Pseudomonas aeruginosa. Our goal for this example is to determine the reproducibility of the data between biological replicates, specifically for strain SH2D. From the GNPS dataset dashboard, we will import 3 files representing biological replicates of this strain. Here are the 3 files of interest: SH2D-1, SH2D-2, and SH2D-3. We're going to select those 3 files, click the Visualize 3 files, and this will import the data into the GNPS dashboard. The files are now listed in the GNPS USI under File Selection. We have SH2D-1, SH2D-2, and SH2D-3. Now the first thing that we want to do is we want to compare the total ion chromatograms of these 3 samples. So under TIC options, we're going to come over here and click to turn on Show Multiple TICs. What this will do is overlay the individual TICs for each sample. Now if we scroll down under Data Exploration, we'll see the TIC plot for these 3 samples. So SH2D-1 is blue, SH2D-2 is red, and SH2-3 is green. Visually, we can see that the TICs of these samples are different. The 2 that are most similar are SH2D-2 and SH2D-3. Most notably, SH2D-1 is missing peaks at about 5.3 minutes and 6.1 minutes. Next, what we're going to do is we're going to take a closer look at one of these chromatographic peaks, and that's going to be the one at 6.1 minutes. Now, we want to know what precursor mass is associated with this peak. So what we're going to do is we're going to scroll back up, we're going to come over TIC options, and we're going to turn off Show Multiple TICs. For this step, I only want to see one TIC because I want to be able to choose a peak and show the MS1 associated with that peak. Because this peak was most abundant in sample 2, we're going to come to the USI view selection. We're going to choose the file for SH2D-2. Now, if we scroll back down to the data exploration, instead of seeing all 3 TICs, we're only going to see the TIC for the second replicate. Now I want to know what the precursor mass is associated with the peak at 6.1 minutes. So all I'm going to do is I'm going to click at the top of the peak. When that happens, an MS1 spectrum is going to load, and this is going to show me the base precursor mass at that peak. So here we can see that that chromatographic peak at 6.1 minutes is associated with the mass 272.20. Next, what I'm going to do is I'm going to scroll back up, and I want to look at this specific mass across all 3 samples. So in the XIC, extracted ion chromatogram, mass to charge ratio, I'm going to put the 272.2. Because this is data collected from a QTOF, I'm going to adjust the extracted ion chromatogram tolerance to 0.05 Daltons. And because we're only looking at a peak at 6 minutes, I'm going to set the retention time window to 4.5 to 7.5 minutes. Now, if I scroll down here on the right-hand side, I can see the XIC plot overlaid for that specific mass for all 3 samples. And sure enough, there's very little of that precursor mass in that first biological replicate. Now, if I scroll down a little bit further, we can actually see the integration data for the extracted ion chromatogram for that peak. So these values are listed as absolute values, and you can see here that the peak for biological replicate 1, SH2D-1, is about 100-fold smaller than the other 2 samples. And you can also see this in the box plot where the first replicate is down here at the bottom close to 0 and the other 2 are towards the top. Other peaks in the TIC plot can be evaluated in the same way. So you can investigate what other metabolites are different between samples. From this visualization, it is clear that replicate 1 of the SH2D samples is different from the other 2 replicates. Quick visualization of the variation in sample replicates within the GNPS dashboard allows us to identify outliers to diagnose upstream data issues. In this case, the source of the variation between samples likely occurred during sample inoculation or during growth. While we show differences in data between biological replicates, the same procedure can be used to compare technical replicates.